Dear students, today we shall solve some problems on continuity and differentiability. The function is continuous everywhere. We should prove the continuity at every point of the real. Here, I will solve some problems on this. Find the relationship. Find the relationship between A and B so that the function defined by f of x equal to x plus 1 if x is less than or equal to 3 and b x plus 3 if x is greater than 3 is continuous at x equal to 3. I discussed this problem yesterday also, but I can't give all the solution of this problem. Therefore, I take this problem again. Find the relationship between A and B so that the function f defined by f of x plus 1 if x is less than or equal to 3 and bx plus 3 if x is greater than 3 is continuous at x equal to 3. Given here the function is continuous. We know that the condition is if the function is continuous at x equal to 3 then LHL limit, RHL limit at x equal to 3 f of 3 all are equal, then only the function is continuous. Therefore, we find the LHL limit and RHL limit and f of 3 all are equal. Equate these 3, we can get the value of A and B or relationship between A and B. LHL is equal to limit of x tends to 3 minus f of x. Here f of x is less than 3. It is ax plus 1. Limit of x tends to 3 minus ax plus 1 which is equal to 3a plus 1. 3a plus 1. And RHL limit which is equal to limit of x tends to 3 plus f of x which is equal to limit of x tends to 3 plus it's greater than 3 is bx plus 3 which is equal to 3 into b 3b plus 3b plus 3. Then f of 3 you can find f of 3 also. F of 3 is equal to 3 is also equal to 3a plus 1. Since the function is continuous, therefore LHL limit, RHL limit and f of 3 all are equal. We equate these 3, we get 3a plus 1 which is equal to 3b plus 3. 3a plus 1 is equal to 3b plus 3. Therefore, we get 3a is equal to 3b plus 3 minus 1 which is equal to 3b plus 2. Therefore, a is equal to 3b plus 2 divided by 3 which is equal to b plus 2 by 3. A is equal to B plus 2 by 3. Or we can find the relationship B also. We can write this one, but B is equal to A minus here. 3B is equal to 3A minus 3 plus 1, which is equal to 3A minus 2. Therefore, B is equal to 3A minus 2 by 3. Therefore, A minus 2 by 3. B is equal to A minus 2 by 3, or A is equal to, or A is equal to B plus 2 by 3. You can write this relationship or this relationship between A and B. A is equal to B plus 2 by 3, or B is equal to A minus 2 by 3 is the relationship between A and B if the function is continuous at x equal to 3. You have to find the relationship between these. This is one more problem. It's very, very important problem, this one. It's asked in the annual question paper, question number 50 or 49, E-type question. It's B part. It's a 4-mark question. It's a 4-mark question. Today I saw these questions. Show that it is one more problem. Show that the function defined by g of x is equal to x minus is discontinuous at all integral points. So that the function defined by g of x equal to x minus, it is greatest integer function. This is greatest integer function. Here it is denoted by square bracket x. It denotes greatest integer function. It denotes it's less than, it is less than or equal to x. Greatest integer, this is called as greatest integer function. Here greatest integer denotes greatest integer is less than or equal to x. Less than or equal to x. You already know here two functions are there. G of x is equal to x minus greatest integer function x. Here let f of x equal to x is continuous because it's a polynomial function. Then h of x or g of x is equal to greatest integer function. Here is discontinuous at every integral point. because g of say g of x equal to here greatest integer function 3 is equal to 3 or 3 my point 1 it's also equal to 3 or 2.9 is equal to 2. Greatest integer means what is the integer lies there. The integer lies in the number. Here 3 is 2.9. Greatest integer value of 2.9 is 2 only. Its the integer is maximum great integer or maximum integer is 2. Here 3 only. It's 2.9 is but it is fraction. Here integer is 2. Therefore, we can write limit of x tends to 3 plus it's equal to 3 is equal to 3 and limit of x tends to 3 minus of 3 is equal to here it's equal to 3 or 3 minus 1 is equal to 2 only. Here 3 minus if we know the graph of the greatest integer function also 0, 1, 2, 3, minus 1, minus 2, minus 3. If the point is here, it's is equal to 0, 1, 0.9 is 0. Here, if it is there, here 2 is 2, so 1, then 0 is here. 0.9 if the 0.9 greatest integer value is 0 only. Greatest integer in this number is 0 only. Therefore, here it is 0. If we want to write this 1 is equal to this or 0 is minus it's equal to this one. Here. Can write that it is greater integer functions are not continuous functions. Greatest integer functions are not continuous functions. Therefore, h of x greatest integer is continuous every integral point. Now we find the LHL and RHL in this function. LHL is equal to limit of x tends to a minus a is an integer belongs to z. A minus x minus integer x. LHL limit x tends to a minus x minus greatest integer function a is equal to a minus 1 which is equal to a minus a plus 1 which is equal to what? RHL. Here limit of x tends to a plus x minus integer function a is equal to a minus a which is equal to 0. Here greatest integer function at positive side. It belongs to z. A belongs to z if it is 3 or 4. It's a positive number here taken or negative number taken. But a minus a plus 1 here because a minus of a minus 1 is negative side of the or LHL part of the LHL side of the function at a. If it is a, we take it as a negative. LHL side, here it is positive side. Therefore, the positive side x minus in the greatest integer is equal to a minus b is equal to 0, but here is 1. Therefore, LHL is not equal to RHL. Therefore, the function is discontinuous. LHL is not equal to RHL. Limit of g of x does not exist. Therefore, the function is discontinuous. Continuous at every integral point. At every integral point. Greatest integer functions are discontinuous functions every integral point. Then we solve some more problems. Finding the k value of the function when the function is continuous at given point. Find the values of k. Find the values of k so that the function is continuous at the indicated point. At the indicated point. First one, f of x equal to k into cos x divided by 5 minus 2x if x is not equal to 5 by 2. Then 3 if x is equal to 5 by 2 and x equal to 5 by 2. Here they given here the function is continuous. The function is continuous at given point x is equal to 5 by 2 and f of x is k cos x divided by 5 minus 2x. 5 minus 2x. If x is less than or x is not equal to 5 by 2 means if x is greater than 5 by 2 then also function is k cos x divided by 5 minus 2x. If x is less than 5 by 2 also k cos x divided by function is 5 divided by 5 minus 2x. But at x equal to 5 by 2 the value of the function is 3. Here we find LHL limit or RHL limit. They are same. Then find the value of the function. They are also given here. We find LHL or RHL. Finding the LHL limit, we write the function k cos x and 5 minus 2 k. X equal to 5 by 2 minus h or t. X equal to 5 by 2 minus h. When h tends to 0 as x tends to 5 by 2. X tends to 5 by 2, x tends to 0, x tends to 5 by 2. We find the LHL limit. Limit of x tends to 5 by 2, k into cos x divided by 5 minus 2x. We have to write 5 minus 2x value, which is equal to 5 minus 2x means x is equal to pi by 2 minus x. 2 into pi by 2 minus x. 2 to 2 pi minus 2 to cancel here. Pi minus pi minus into minus plus 2x. Pi minus pi cancel. It is equal to pi minus pi cancel. 2x is equal to there we have to write here 2x is equal to 2 into pi by 2 minus h. Therefore, 2x is equal to 2 into 2 cancel 5 minus 2h. 2x equal to 5 minus 2h. To put the value of this one here, limit of x tends to 5 by 2, then h tends to 0. H tends to 0. H tends to 0, x tends to 5 by 2. Therefore, I write it as limit h tends to 0, k into cos x means x is equal to 5 by 2 minus h. Cos 5 by 2 minus h. Then 5 minus 2x is 5 minus 2h, which is equal to cos of 90 minus theta. 90 minus theta is sin theta. Therefore, limit of h tends to 0, k into sin h divided by 5 minus 5 is just cancel, minus into minus plus 2h. Yeah, 2h. Therefore, the limit of the function we taken here k by 2 is a constant. Limit of x h tends to 0, sin h by h, which is equal to 1. Which is equal to 1. Therefore, is equal to k by 2 is equal to into 1, which is equal to k by 2. Therefore, LHL or RHL limit is equal to k by 2. Then find the value of f of 3. F of 3 is equal to f of 5 by 2 here. X equal to 5 by 2. F of 5 by 2 is equal to 3. Therefore, the function is continuous. Since the function is continuous at x equal to 5 by 2, therefore k by 2 LHS is equal to f of 5 by 2, which is equal to k by 2 into is equal to 3. Therefore, k is equal to 6. K is equal to 6. First, k here we have to put k is equal, x is equal to 5 by 2 minus h or 5 by 2 minus theta, or you take x cos x equal to something you take here, then only we solve the problem easily. First, we have to find the limit of the function LHM or RHM, the same. Then find the value of the function at 5 by 2 also given here. It's 3. Then equate these two. We get the value of the function and k value is equal to 6. The function is continuous. Therefore, we equate the LHL limit and f of 5 by 2. We get the value of the k which is equal to 6. It's very important problem. So many times asked in the annual exam also. Then we start one more problem on the same type. Second problem. Here also the function is continuous. F of x equal to kx square if k x square if x is less than or equal to 2. X square if x is less than or equal to 2. 3 if x is greater than 2 and x equal to 2. Here also the function is continuous at x equal to t, x equal to 2. If the function is less than 2 is k square and greater than 2, the range of the function is 3. Then we find the LHS limit and RHS limit and f of 2 also. Then we equate the LHS here, LHS is equal to limit of the function x tends to 2 minus, which is equal to limit of x tends to 2 minus f of x is kx square. Kx square, it's the polynomial function. Therefore, we put the value here on the limit of k into x square is 2 square, which is equal to 4k. Then RHS limit of x tends to 2 plus f of x, which is equal to 2 itself. Then 3 x is greater than 2, it's a constant number, therefore the limit of the function is 3 itself. Therefore 4k here is 3 and f of 2 also k into x square is 2 square is equal to 4k. Since the function is continuous, you have to write all the steps. Don't forget to write. First find the LHS, RHS and f of the function value of the function at given point. Since the function is continuous at x equal to 2, then LHS is equal to RHS is equal to f of 2. Therefore, here the function is 4k, LHS is equal to 4k and RHS is equal to 3. Therefore, k is equal to 3 by 4. The answer of the k or problem is k is equal to 3 by 4. It's very simple problem. Here find the value of LHS and find the value of RHS and equate these two. We get the, by solving, simplifying, we get the value of t. Let's solve one more problem. Third one. F of x, which is equal to kx plus 1 if x is less than or equal to 1. Then cos x if x is greater than 5 at x is equal to 5. Here also the same type problem. At x equal to 5, the function is continuous. It's kx plus 1 if x is less than or equal to 5 and cos x if x is greater than 5. We find the LHS limit and RHS limit is equal to limit of x tends to 5 f of x 5 minus, which is equal to limit of x tends to 5 minus kx plus 1, which is equal to k5 plus 1. Then RHS is equal to limit of x tends to 5 plus n greater than 5 f of x, which is equal to limit of x tends to 5 plus cos x, which is equal to cos 5 cos phi. Cos phi is the value of the cos phi is equal to -1. Yes, -1 you know in the already in the first video. Then put the value here. You can find the value of the function f phi. F of phi is equal to kx k phi plus 1, which is equal to 5k plus 1. Since the function is continuous, the function is continuous. At x equal to 5 by 5, x equal to 5. Then you can write LHL is equal to RHL, which is equal to f of 5. LHL is equal to kx k 5 or 5k plus 1 is equal to -1. Then the function is k phi, which is equal to plus 1 minus here -2. Therefore, k is equal to -2 divided by 5. This is the answer. K. Here, all the steps are same. I taking here all the same type of problem in this today. These are asked in the probable questions in E-type questions. It's a part B. Part B. E-type 49 or 50th question, part B questions. Here, you have to find the k value when the function is continuous at a given point. I saw one more problem, and many problems are there in the 5.1 exercise. You solve other problems, and if you have any doubt, please ask me or call me. Another problem, fourth one. F of x is equal to kx plus 1 if x is less than or equal to 5, 3x minus 5 if x is greater than 5 at x equal to 5. Here solution, we have to find x equal to 5 continuity or equate the LHL and RHL and f of 3 at x equal to 5. LHL limit is equal to limit of x tends to 5 minus f of x, which is equal to, we have to write this one RHL and f of 5 also. We have to find all these things. Limit of x tends to 5 minus f of x is here less than 5 is LHL is kx plus 1, kx plus 1. Here RHL is equal to greater than 5 is limit of x tends to 5 plus here f of x, which is equal to limit of x tends to 5 plus the function is 3x minus 5. 3x minus 5. Then f of 5 is equal to 5. The function is kx plus 1. We put the value here. F of x is equal to, at x equal to 5 is equal to kx plus 1. Kx plus 1. Therefore, we put the value here. Kx plus 1. 5k plus 1. 5k plus 1. Here 3 into 5 minus 5. Therefore, 15 minus 5, which is equal to 10. Here also k 5k plus 1. We equate these things. Since the function is continuous at x equal to 5. The function is continuous at x equal to 5. LHL limit, RHL limit is equal to f of 5x. LHS is equal to 5k plus 1, 5k plus 1, which is equal to RHL, it's 10. This also 5k plus 1. We equate these two. 5k is equal to 10 minus 1, which is equal to 9. Therefore, 5k is equal to 9. K is equal to 9 by 5. K is equal to 9 by 5 is the answer. Yeah, all these problems are very, very important. You solve these problems and not only you prepare your studies, these type questions. One more problem, fifth one, it's different from this one. Discuss the continuity of the function. Discuss the continuity of f of x, which is equal to 1 minus cos x divided by x square if x is not equal to 0 and 1 if x is equal to 0. 1 minus cos x divided by x square if x is not equal to 0, 1 if x is equal to 0. Here the question is discuss the continuity of this at x equal to 0. At x equal to 0. Here also we find the continuity at x equal to 0, LHL and RHL and f of 0. LHL at x equal to 0, LHL which is equal to limit of x tends to 0 minus. Here LHL and RHL are 1 minus function is 1 minus cos x divided by x square, because if the function is x is greater than 0 also this function, x is less than 0 also this function. If x equal to 0 is the function is 1. Therefore 1 minus cos x, here we have to find LHL and RHL at once for the, which is equal to, here 1 minus cos x, find the limit of the function by substituting 1 minus cos x is equal to 1 minus cos x is equal to 2 sin square x by 2. 2 sin square x by 2. Limit of x tends to 0 minus 2 sin square using identity divided by x square. Then I put the split this by 2 into sin x by 2 divided by x by 2 into sin x by 2 divided by x by 2. I multiply it 2. It also multiplied by 2. I get the value 2 to cancel x. Here also 2 to cancel x. The sin square x by 2 is multiplied by 2. We get the same. Then limit of x tends to 0 minus. Here also limit of x tends to 0 minus. We get the value of this one is 1. Here also value of this one is equal to 1. Therefore, here 2 by 2 is cancelled. The value of the function is 1 by 2. Here 1 divided by 2 is remaining. Therefore, the value of the function is limit of this function is and then is equal to 1 by 2. This is equal to RHL also. Then f of 0 is equal to 1. They are given f of 0 is equal to 1. Therefore, equating these two, but here LHL is equal to RHL, but it's not equal to f of 0. F of 0. 1 by 2 is not equal to 1. Therefore, the function is discontinuous at x equal to 0. Therefore, the function is discontinuous at x equal to 0. Thank you. You solve other problems in the exercise or 5.1.